morning, welcome to new lecture. Today I will solve several examples using slope deflection method, and I will emphasize on sign convention on slope deflection. Different textbook, they have different contracts. Some of them clockwise is positive, some of them counterclockwise positive. Slope deflection equation I'm using, for example, MAB is equal to M fix AB plus 2EI over L 2 theta A plus theta B minus 3 psi. These are rotation. This belongs to the settlement or lateral deflection. Here I assume counterclockwise positive, counterclockwise moment is positive, so counterclockwise fixed moment is positive as well. Counterclockwise rotation is positive, and about psi, for example, point A, point B and point A, elevation is different, or we have settlement. In that case, with one straight line attach A to B, and look at to this rotation. If this rotation is clockwise, means put psi is equal to negative delta over L. So this negative delta over L you will plug here. Or if you see like this, point A, point B, you see this is counterclockwise, so psi will be positive delta over L. Put positive delta over L here. If rotation is clockwise, negative delta over L. If rotation is counterclockwise, positive delta over L. So moment counterclockwise positive, fixed end moment counterclockwise is positive, rotation counterclockwise is positive. If you watch the first video, I wrote formula like this. It is the same thing. Maybe I should emphasize on that. MAB is equal to M fix AB plus 2EI over L minus 2 theta A minus theta B plus 3 delta over L. It is the same thing. The reason I put negative here, because that picture I drew it and I prove slope deflection. If you look at to that picture, rotation is this kind of rotation we have. Sorry, if you look at to that picture, rotation is this kind of rotation. So the picture I draw with rotation is clockwise. Clockwise rotation, because counterclockwise I assume is positive. Clockwise rotation, it will be negative. So you will plug here negative. Negative will be positive. Again, this theta B, it is clockwise. So you will plug negative. Negative will be positive. And here, the psi over there, I assume once it moves down, this is positive. So you will plug here. Maybe that will confuse you. So from this point of time, I will follow this one. This is the better. If you see, rotation is counterclockwise, means plug positive here. Or if you end up with theta is equal to positive number, means that rotation counterclockwise. If you end up with theta is equal negative number, means that rotation is clockwise. And for psi, I said, if we have 2 points A and B, attach these 2 points using one straight line, look at to this angle. If this is clockwise, so psi will be negative delta over L. If it is like this, counterclockwise psi will be positive delta over L, then you will plug here. Of course, any direction you assume positive, no problem. You can assume inverse direction is positive, like clockwise. As long as you are consistent, you will end up with right answer. I think in one example I made mistake. I'm not sure, but please watch those videos. If you see I made mistake, correct that. I think in one example I made mistake, but let's see today. I will review several examples. So these examples hopefully will clarify positive and negative. We have this beam. I think I should change my marker, but let's see. A, B, C. We have settlement at support B and C, both of them. So settlement support B is delta. At support C it is again delta. We have this beam. The length for each segment it is L, L, EI, EI is constant. We have settlement at point B, at support B and support C. We want to find MAB reaction at support A. We know MAB is equal to M fix AB plus 2EI over L 2 theta A plus theta B minus 3 psi. M fix AB, here it is equal to 0 because we don't have external load. So this will be equal to, MAB is equal to 2EI over L. Theta A here is 0 because it is fixed support. 2 theta A is 0 plus theta B minus 3 psi. Let's see what is the psi here. B will transfer here. So if I attach, this psi will be clockwise. So psi will be negative delta over L. Negative because it rotates clockwise, delta over L. If I plug there, it will be, this term will be positive. Negative times negative positive, 3 delta over L. This is MAB. How about MBA? MBA will be M fix BA, again it is 0 plus 2EI over L 2 theta B plus theta A, which is 0 minus 3 psi, that is equal to 2EI over L 2 theta B minus, again here the psi will be negative delta over L, this will be plus 3 delta over L, and this term is 0. We know that this theta A is 0. How about MBC? MBC will be equal to M fixed BC plus 2EI 2 theta B plus theta C minus this will be psi AB, psi BA minus 3 psi BC. Because both support settlement are equal, this part there is no any lateral deflection B respect to C or C respect to the B. Both of them it is in the same level. So this term is 0, this term is 0. I will have theta C is equal to 0 because it is fixed support. This will be 4 E I theta B over L. At joint B, because this is continuous, I know M BA plus M BC is equal to 0. So if I plug, I will have 2EI over L, 2 theta B plus 3 delta over L plus 4EI over L, theta B is equal to 0. From this equation, I can write 8EI theta B over L plus 6EI delta over L square over is equal to 0. From here, theta B will be equal to negative 3 delta over 4 L. Now, I want to find MAB. I should plug this theta B here. If I do that, what I will get? MAB will be equal to 2EI over L minus 3 delta over 4 L plus 3 delta over L. This will be 2EI over L 4 L 4 times 3 12, that will be 9 delta. This will be 18 EI delta over 4 L squared. That will be 4.5 EI delta over L squared. Now, the final answer for AB, it is positive. It means this reaction should be counterclockwise direction. Theta B is negative, means that this joint, if we have settlement, it will rotate clockwise, something like this. You see the deformed shape. Let's I draw one more time with other color, another color. Something like this. Of course here, this is wrong, sorry, I should correct this one. Here, the tangent should be horizontal, so it will be something like this. Okay, let's look at to the next example. Next problem. Again, we have settlement, it is beam. But we have different EI for different parts. What we have is this beam. A, B, C, length here 2, L, L. We have settlement delta at support C, and EI for BC part it is 2 EI, for AP part it is EI. So we have this beam, AP part length is L, BC part it is 2L, EI for AP it is EI, for BC it is 2EI, 2 times bigger. Settlement we have at support C is equal to delta. We want to find M, A, B fraction at support AB. Let's see what we can write here. Again, I can write MAB is equal to M fix AB plus 2EI over L 2 theta A plus theta B minus 3 psi. Theta A is 0 because this is fixed support. M fix AB is 0 because there is no external load. We don't have any settlement. No, here I made a mistake. In problem statement we have settlement at support C and settlement at support A. Both of them is delta. So we have this beam. This beam it is, you see, continuous beam. We have two parts, span AB, BC. AB part length is L, BC part it is 2L, EI, 2EI. We have two settlements. Settlement at support C is equal to delta. Settlement at support A again is equal to delta. We want to find MAB. MAB slope deflection equation. M fix AB, fixed end moment because of external load is 0 because there is no external load, 2EI over L. 2 theta A is 0 because there is no rotation at this support and it is fixed support, so theta A is 0. Theta B minus 3 psi. Psi here, A, B, A initially, B, then it is like this. So it will be counterclockwise. Psi will be this delta over L. So psi will be delta over L. If I plug here, this will be equal to 2EI over L theta B minus 3 delta over L. M B A is equal to M fixed BA plus 2EI over L 2 theta B plus theta A minus 3 psi. Here M fixed BA is 0, so we don't have this term because there is no external load. 2EI over L 2 theta B, theta A again it is 0 minus, again psi it is the same thing. This is psi AB, this is psi BA, both they are equal, minus 3 delta over L. Let's look at to MBC. MBC is equal to M fixed BC plus 2ei over L 2 theta B plus theta C minus 3 psi B C is equal to M fixed BC. M fixed BC. There is no external load, it is 0 plus 2ei over L 2 theta B theta C. There is no rotational support C and it is fixed support, so that is 0 minus, let's look at to the BC, psi BC. This is support B, support C initial is here, moves here. So in this direction psi. So psi, because it is rotation clockwise, will be negative delta over L. So will be negative delta over L. Negative times negative will be positive. This will be 3 delta over. The length for this span, it is 2L. 3 delta over 2L. And we have negative here, negative delta over 2L, because the length for BC is 2L. Negative times negative, positive 3 delta over 2L. On the other hand, this is 2ei. So 2ei we have in the formula, 2 times 2ei, this will be 4ei. And the length again, 2L. Formula is like this. But EI for BC part, it is 2EI, and L means LBC, that is 2L. So instead of EI, we will plug 2EI, 2 times 2 will be 4EI, divided by 2L. From here, we can write now equilibrium equation. Equilibrium equation at joint B, it is continuous member, so MBA plus MBC should be equal to 0. Summation of moment in all rigid joint should be equal to 0. This we can say from equilibrium. Now I have MBC, I have MBA, I will plug here. I will have 2EI over L 2 theta B minus 3 delta over L plus 4EI over 2L times 2 theta B plus 3 delta over 2L is equal to 0. From here we can find theta B is equal to 3 delta over 8L. Now if I plug this theta B here, what I will have, if I plug that theta B in that equation, M A B will be equal to 2EI over L 3 delta divided by 8L minus 3 delta over L. This will be 2EI over L. Here this will be 8L. That will be 3 delta minus 24 delta. This will be negative 21 delta over 8L times 2EI over L, it will be 20 minus 21 times 2 times EI times delta over 8L square. This will be equal to negative 5.25 EI delta over L squared. Okay, let's look at to the next example. Next one, we have this beam. This part is rigid. L, A, B, C, this is EI. We have settlement delta at support C and settlement delta at support A. We want to find MAB. MAB will be equal to M fix AB plus 2EI over L 2 theta A plus theta B minus 3 psi. Now, M fix AB, it is fixed end moment because of external load. There is no external load, that is 0. 2 theta A, because it is fixed support, there is no rotation here. This term again is 0. So I can write this is equal to 2EI over L theta B minus 3 psi. Let's see now. What is the theta B? Theta B here, if this support settles respect to the B comes here, and this is rigid, so there is no deformation, it will remain like a straight line. And this will be tangent to that, it will deform like this. So this rotation, you see, it is clockwise rotation. We know here theta B. We know theta B here is equal to delta divided by L. Delta divided by L. Because this is a straight line, after deformation remains straight line. In this triangle, delta over L will be theta B, and it is clockwise, so it is negative delta over B, because you see this will remain tangent, so in a straight line direction goes like this, and this rotation is clockwise. So instead of theta B, you can plug minus delta over L. Psi here, it is psi AB. How about psi AB? Point B, point A initially. Then we have settlement at support A delta. This psi counterclockwise, so we will plug positive delta over L delta over L. So it will be equal to 2ei over L minus delta over L minus 3 psi will be delta over L. This will be equal to negative 8 ei. Let's see, this will be 8. Yes, this will be negative L for delta, so it will be negative 4 times 2, 8 ei. Delta over L squared. M A V. Okay, let's look at to the next example. Next example, we have this beam. Subjected to concentrated load at mid-span. The length is L. Here we have rotational spring, and stiffness for this rotational spring, it is given 2ei over L, point A, point B. We want to find internal moment M in spring. We want to find moment inside of a spring after deformation. Moment in the spring will be M. B will be rotation at point B, which is theta B, times the stiffness of the spring, K theta. That will be equal to 2ei over L times theta B. If I write the slope deflection equation, MBA, which is equal to MB here, that is equal to M fixed BA plus 2ei over L, 2 theta B plus theta A. There is no settlement, so that term is 0. So instead of MB, I can plug 2ei over L theta B is equal to M fixed BA, fixed end moment, concentrated load, it will be PL over 8, and it will be clockwise, so negative PL over 8 plus 2ei over L times theta A is 0 because fixed support, 2 theta B. From here I can write 2ei over L theta B minus 4ei theta B over L is equal to negative P L over 8. From here, this will be negative 2ei theta B over L is equal to negative P L over 8. Negative and negative, they will cancel from both sides. So theta B will be equal to PL squared. PL squared over 16ei. 16ei. If I plug this here, I will have 2ei over L times P L squared over 16 EI. EI cancel. This will be P L divided by A will be moment inside of spring. Okay, thank you so much for watching this lecture. See you next session. Bye bye.